distribution probabilities. So what we do to find the probability of a normal distribution is we actually find something called the z-score. And this is calculated by calculating x minus mu over sigma. So that just means like the data that we want to find minus the average over the standard deviation. And this indicates the number of standard deviations basically away from the mean that data point lies. So a z-score also converts a particular normal distribution to the standard normal distribution. So z-scores can be used with the areas under the normal distribution curve to find probabilities. And that's basically what we're doing. So we know that the area under the curve is going to equal 1, and therefore we're going to find, what we would do is like find the area under the curve and then of course put it over 1. Okay, so the area under the normal distribution curve is equal to 1. We already said that. And probabilities for normally distributed populations, as for other continuous distributions, are equal to the areas under the distribution curve that go from A to B, whatever A is to whatever B is. So if you're going for like IQ scores with over here equals 0, then A could be, let's just make, like say it's out of 100, maybe a test score. Let's say A is 70% to B being maybe 83%, just for an example. So we would find all the areas under here divided by 1. Okay, so let's actually take a look at that. Okay, so a cola factory aims to put 355 milliliters of cola in a can of pop. Okay, so the actual amount of cola in a can is normally distributed with a mean of 355.5. Okay, and a standard deviation of 2.85. So if you actually think about it, like 355 milliliters, that's just like a normal can of like Pepsi or Coca-Cola, whatever it is. But on average, they actually put a little bit more in your can, okay? And then the standard deviation is 2.5. So they could put a little bit more in your can or a little bit less. And both these would be measured again in this milliliters. Okay? The manufacturers want to ensure that each can contains at least 349 milliliters of cola. Okay, what percent of pop cans do not contain this much cola? Okay, so what I would do first is I would draw my normal distribution. Okay, in the middle, that's always mu, so we have 355.5. And our cutoff here is 349. 349. So what we would do is we would use the z-score. So let's take a look. So z equals x minus mu over sigma. Okay, our x that we want, our cutoff point is 349. Okay, so 349, and we want to compare that to the 355.5. Okay, and it's over sigma, so over 2.5. When we calculate that, 349 minus 355.5 divided by 2.5, I do it all in one shot. I get negative 2.6. What this means is that this number, 349, is 2.6 standard deviations away from the mean, but since it's negative, it's actually 2.6 this way. So maybe 1, 2, and then 0.6, like a little bit more. Okay. Now, what we want to do is we want to look up this z-score in the normal distribution table. So I'll show you what that looks like. Okay, so this is what this looks like. We're looking at the number negative 2.6. So what we do is we look at the z-score. So this side is the negative, and then this side's the positive, and it says here negative z-scores and positive z-scores. So what we want to do is we want to scroll all the way down to negative 2.6. Now, our answer is negative 2.6, and it was already rounded, I believe. Just double check. Yeah, so it was already rounded negative 2.60. So this is going to be your whole number in your first decimal, so the tenths place. And this here, what we're looking for is the hundredths place. So this would be negative 2.60, negative 2.61, negative 2.62. So we're looking at this hundredths place. We can just focus on negative 2.60. So that gives us a probability of 0.47%. So 0.0047, or if we look at it in percentage, 0.47%. So going back to this page, 2.6 standard deviations lower than the mean equals the probability of x. We can actually do the probability of x being less than 249. And that's 0.49%. You say 49? Sorry, 47. 47%.